Okay, so we're talking about just the properties today. Just the properties. So let's start with commutative. Commutative. These are the commuters. So commutative means that the order does not change the sum. So you can mix all the numbers around, but it doesn't change what they equal. Okay? So it's like when I commute, I drive to work 2 miles, and then when I drive back home, it's still 2 miles. Okay? So I change the order or the direction, but it doesn't change the amount. Okay, so here's an example. You could have 6 plus 1, and it's the same thing as 1 plus 6. Or you could have 7 times 3, and that's the same thing as 3 times 7. Does commutative work for subtraction? No. How about division? No. So pretty much just addition and multiplication, right? Okay. The next one is called associative. Associative. This is the way numbers are grouped, does not change the sum. So this is more dealing with grouping. Commutative is order, associative is grouping. I always think commutative, commuting, like you're driving, walking. Associative is like the associates in a group. That helps me remember. So the way the numbers are grouped does not change the sum. So example. 2 plus 3 plus 8, and there's generally parentheses around these, equals 2 plus 3 plus 8. It's just grouped differently. Zoom that in for you guys. The same thing works for multiplication. You could have 2 times 3 times 8 or 2 times 3 times 8. Just change the parentheses. So neither one of these would work for subtracting or dividing unless you kept, on associative, if you kept the same exact order of things. But you'd have to really think about that when you're doing like your GEMS or your PEMDAS. So there are a few exceptions where subtraction will work here, but not necessarily division. Any questions on those two properties? We use these properties over and over and over in math. Sometimes we just don't know what they're called, but we do use them. Okay. All right, the additive identity is when 0 is added to any number. What happens when you add 0 to any number? It stays the same, which is its identity, right? It stays the same. Okay, so a plus 0 is a, 1 plus 0 is 1. That's called the additive identity. So you're just adding 0. Okay, the next one is called the multiplicative identity. I just put ID for identity for you guys. That's when any number is multiplied by 1. Any number multiplied by 1. Multiplicative identity. What happens when you multiply a number by 1? It stays the same. So that's what that identity means again, right? It stays the same. So an example would be a times 1 is a, and 2 times 1 is 2. You raise your hand if you've heard of these 4 properties before, or at least one of the 4. Good. They start teaching you some of these in 2nd grade. So that far back. Questions? Yeah?
Isn't multiplicative the same thing, like multiplicative inverse, the same as reciprocal?
Yes,
So,
it
like,
can be.
how would that be, like, multiplicative when multiplied? Like, I don't.
When you multiply by that fraction.
Oh.
We'll get to that later.
Okay.
Okay?
Yeah.
All right. Is ready?
Well, no.
No?
Yeah.
So remember, additive identity is when you add 0. Multiplicative identity is when you multiply by 1. The end result is that you get the same number or letter. Okay. Then we have the multiplicative property of 0, which states that any number multiplied by 0 will be what? 0. So that's called the multiplicative property of 0. Any number multiplied by 0 is 0. This goes back to first grade when you start learning your math facts. So any number multiplied by 0 is 0. Okay, so that was 5 properties, right? Yep, 5 properties, and then I'm going to give you some examples, and then I'll give you some practice work, and there's only 5 problems of homework tonight. Yay! Okay, so here is the first example. It'll say something like simplify and justify each step. Now, you'll have to be able to do this on the quiz and on your test this chapter, so we're going to practice quite a bit. Okay, so simplify. So if they give you 7 plus g plus 5, 7 plus g plus 5, then that's the same as g plus 7 plus 5, right? I'm trying to combine my numbers. And when you change the grouping, that's the associative property, so that's the justification part of this. So write associative property next to that. And then after that, what would you do? After you got 7 plus 5, what is 7 plus 5? 12. So you can rewrite it as g plus 12, and that's simplifying. And that's as far as you can take it, because you cannot combine the 12 with the g. So you just leave it as g plus 12.
Could you also say like 12?
No, can't combine them. If it was multiplying, you could. Okay? So all we did was regroup, and we call that associative, and then simplify. So in the homework and the practice, when it says justify your steps, you're looking to write something like that. Simplify is always the last step, right? So you should get that one right on the quiz. Yeah. We're going to do that one tomorrow, I believe. Yeah. Okay, example 2. Here's a multiplying one. So we have m times 11 times m. M times 11 times m. Now, a lot of people do these in different order, and that's okay. So whatever order you do them in, that's the property you'll write down, okay? But if you want to see it broken down, you could pull the 11 out and then do m times m. So that's just regrouping. That's associative. And then 11 times m times m. What's m times m? What would we write for that? Anyone know? M squared. Good. So 11m squared simplified. That's it. Okay, so any number or letter times itself is just the squared symbol, right? Any questions? You know what they're asking for when they say justify? They're just asking for the property that you used. Okay? All right, so the practice is 371 and 372. The homework I wrote on the board, probably most of you will get through that as well. You have about, what, half an hour to do all these? So when everyone's finished with the practice, we'll go over this, but it's 371, 1 through 4, 7 and 8, and 372, number 13. And then the homework is up here too.